Number 12. A ray of light is incident on the midpoint of a glass prism surface at an angle of 25 degrees with the normal. We're given the index of the glass. The prism apex angle is 30 degrees. That's this angle right here. Is going to be 30 degrees. What's the angle of refraction as the ray enters the air on the far side of the prism? So I drew my normal here already, and I'm going to be incident at 25. So I'm going to be incident this way. That line's pretty bad. Let's try that again here. Alright, so that's theta 1 here. And that's the one that is given as 25. I'll go ahead and write the givens here because we're going to have a lot of different angles in this problem. So theta 1 is going to be 25 degrees. So N1 is going to be air, so N1 is going to be 1. We're incident onto the glass. N2, which has an index of 1.55. And first thing we need to do is figure out what's going to be this angle of refraction here. It's going to refract towards the normal here. So we need to find this angle here, which is angle theta 2. So we're going to use Snell's law. N1 sine of theta 1 equals N2 sine of theta 2. And again, solve for theta 2. We'll have the inverse sine of N1 sine theta 1 over N2. And I got an angle of 15.82 degrees. That's definitely not the final answer. That's just the angle of refraction here into the glass. But now what's going to happen is this ray here is going to exit the glass. So I'm going to draw my normal again. So my normal is here. Sorry, it's hard to draw a straight line here. And I know that I'm entering glass where light is faster, so I'm going to refract away from the normal. I'm not drawing it perfectly to scale, but we have a small angle here, small angle of incidence, and we have a larger angle here, angle of refraction, that we're going to need to find. So the way that I labeled my angles is, well, I need to find this angle here, this little one here. So since I know that these two, this one and this one, equal 90 because this is my normal, this is 90, then I need to find this angle first. To find this angle, I need to figure out my three angles here at my triangle. We know that we always have 180 degrees in a triangle. So if I knew this angle and I know 30, then I could find this one. So my first step is to actually figure out what this angle is right here. So I call this one theta 3. So theta 3 and theta 2 form a right angle. So I know that theta 3 is just 90 minus theta 2. So it's going to be 74.18 degrees. Now that I have theta 3 and I have 30, I know these three will add up to 180 degrees. So I went ahead and called this theta 4. So I know that theta 4 is equal to 180 minus 30 minus theta 3. And that's going to equal 75.82. So now that I have theta 4, I can find this little angle right here, which I call theta 5. So because theta 4 and theta 5 make a 90-degree angle, so I know that theta 5 let's try that again here, equals 90 minus theta 4, which is going to be 14.18. So degrees. So now we have theta 5. So I'll call the index where theta 5 is, I'll call it N5. So we're in glass. So I'm just redefining my glass index as N5. And we're going into air, which I'll call N6. And I'll call the angle of refraction theta 6. So N6 is going to be air. It's going to be 1. And we're looking for theta 6, so we need to use Snell's law, and 5 sine of theta 5 equals N6 sine of theta 6, and solve for theta 6. We'll get the inverse sine of N5 sine theta 5 divided by N6, and you plug in N5 and 6 and theta 5 in there, and you should get theta 6 equal to 22.3 degrees.